So let's see. We talked about being able to access the database using the mongoose library, and we showed you how to do it manually using the Mongo client, and we realized that MongoDB does not support many of the abstractions that folks like us coming from a relational database we're expecting. So we're expecting schemas. We're expecting some validation from the database, and we realized that Mongo doesn't do any of that. Right? That instead it relies on the application level logic to take care of that. Right? And us expecting a lot of that to happen automatically. Instead of us doing it manually, we decided to use a library called Mongoose, Mongoose.js. And there's quite a few other alternative libraries out there, but we're using one, particularly one that it's fairly common. We used Mongoose library to be able to declare schemas such as this, where we can describe, right, the various data fields and data types of what describes a user, such as usernames, passwords, first name, and so on and so forth. Alongside with a schema, we also declared a model, and we described the model as a module that allowed us to manipulate that data, or allowed us to handle the life cycle of instances of these entities. In this particular case, it's a user, so we should be able to implement 4 of the CRUD operations, right? Being able to create new instances, read instances, be able to update instances, and also remove instances. And I left that for you to do, right? So we encapsulated all this logic inside of a Node.js module, and we exported it, right? So what we did is that we enhanced the Mongoose model. We enhanced it by adding an API to it, right? Adding all these functions to it, and then exporting it to anyone who wants to use this, right? And once we exported it, we could then load it from, say, the service, and then use it to re-implement the endpoints, right? The web service endpoints. So, for instance, we refactored the implementation of the update user. Instead of searching the local array, the hard-coded array, instead we replaced it with retrieving it from the database, right? From updating the actual database. We also did the same thing for registering. Instead of pushing to the local array, we inserted the user into a database, right? Same thing with find user, right? We re-implemented it, so we can remove all this stuff, right? We don't need it anymore because now it's being implemented by the database instead, right? So we can remove all this. Yeah. So notice that one of the benefits of implementing everything inside of a model and also inside of a module. Notice that we created an API, right? That provided the outside users, right? Such as this service, provided it with a high-level abstraction of manipulating this data. Right? Notice that underneath, this function has no idea that underneath we're even using a NoSQL database. Right? This could have been, as far as this is concerned, it could be a SQL database, right? Or it could be an XML file, or it could be a text file, right? So behind this function, behind the function, we have the actual implementation. Right? And that's a very common practice, right, of encapsulating the data access, right, through a thin layer that does a conversion between these two worlds. notice that all these files are doing the same thing. Notice that this service also is a thin layer, between two worlds, right? It's this service has the name service, right? Because it has a very specific role, right? It sits between two worlds. It sits between the HTTP world, right? And there it is, right? There's the HTTP world. It's listening for incoming HTTP request. It's a world of streams. It's a world of bits being streamed across a wire. So it converts between that world and an object-oriented world, some JSON representation represented in some RAM, in some language, in some executing machine on the server. Yes, so that's why it's called a service. Okay, that's because it's doing that this particular role. And then notice that this model, the user model, it's called a model because again, it is providing a specific role in the application. Again, it's wrapping the data. It's wrapping the data with a very well-defined set of actions that manipulate its life cycle, being able to create instances of these entities, being able to retrieve them by some unique identifier, update a particular instance, right, with a new data, and also retrieve them using any number of queries. That makes sense? So again, the model plays also an important role of sitting between two worlds, right? The application world that is usernames and passwords and objects that represent users and websites and whatnot, right? The domain objects, and then the actual low-level storage of this in some file. Yes, that makes sense. So that's why we refer to these applications as multi-tiered applications, right? Where you have multiple tiers, each tier responsible for a particular role in the application. Make sense? Right? There could be many other tiers that we're not considering. There might be a business logic tier in between here that could implement lots of rules, logical rules that I don't know. Maybe if you try to withdraw an amount of money, obviously you can't do it if it's less than whatever your balance is. Things like those rules of a particular business. Or you can't, if you already withdrew $500, then you can't withdraw again unless within 24-hour period. Those are all business logic, business rules. Again, very typically, there would be another tier in between here, right? That would sit between the service layer and the data layer, right? That would implement all these rules. Yes, we're not doing that, but we can certainly consider that could be part of an extended architecture to our application. Yes, that makes sense, right? Again, that's why oftentimes these are referred to as multi-tiered applications. One bad practice would be to allow access to a database from anywhere you want. Okay. I mean, it still happens today that you see, old code, legacy code that developers, whenever they needed to access a database, they would get a connection, they do a SQL query, they get the results, they display it, they do whatever they need, anywhere in their code, and that's a very bad practice. Makes the code very, very hard to debug, very hard to go forward. Instead, today, the accepted implementation is to encapsulate that, all the data access encapsulated in a very well-defined set of classes that are their only role. Okay, so if ever you need to access database, you wouldn't actually use a low-level mongoose to access database. Instead, you would use some kind of wrapped API around that. Make sense? As oftentimes, this also is referred to as a data access object. Right? It's a design pattern. DAO, oftentimes referred to as a DAO. But again, the database course deals with a lot of that. All right, so today I wanted to discuss a couple other things. In our data model, obviously we have more than just users, right? We have websites and pages and so on and so forth, and they have relations with one another, right? We have that users or developers create websites. The relationship is create, okay? And then websites themselves have relationships with other domain objects such as pages, right? A website is made up of, right, or has many pages, right? So again, the relationship is has many, right? Has many pages. So I'd like to discuss various ways that this could be implemented, right? Your assignment suggests one way to represent it, actually two ways of representing it, and I'd like to explore both of them. All right, so let's do that next.